Okay, chapter 1. We're going to get started with curves. And I'm going to cover in this section the various curves that we have and a couple of new features with Blender 2.8, at least for me, that I wasn't aware of in 2.79. So I'm in Blender 2.83, and you should be able to see this from here on out regarding curves. So what is a curve and how is it different from a mesh? I want to cover that very quickly. So when I come into our default cube, notice how as a 3D object, a cube is made up of vertices. And a vertex by itself, obviously, if I hit A and S and then 0, we have one vertex, right? If I merge to the center. And a vertex by itself is nothing special. As I extrude it out, we can make a line, and it's a linear interpolation between 2 points. Extrude it out again, and join those all together with F, and you can make a plane. And we all are pretty familiar with that as we work in Blender. Planes are really fun. You can start, extruding out more edges together, make more planes and polygons, and this is one way of modeling. Now curves are a different approach to modeling, but they still provide a lot of value. But they're not the same thing as a mesh, but they can be converted back and forth, if that makes sense. And you can convert certain meshes to curves, and you can convert curves to meshes. So let's go and delete our destroyed default cube. And if you go to Shift A on your Add menu, right below Mesh is the Curve menu. Curves are split into two different types. We have Beziers, a Bezier curve and a Bezier circle, and we have NURBS. And I'll explain the differences. Let's just go ahead and add one. And as we add a curve, it default starts flat on the X and Y axis. And why does it do that? I always wondered how come I can't see it going up. And this is probably the designers of Blender and the devs probably did this for 2D artists, because as you can swap between 3D and 2D, typically we're working in the XY space. In the 3D world, we work in the Z space. That doesn't mean that a 3D curve can't go up. So if I were to click on this curve, I can definitely move it up in the Z axis, and I can move it in the X and the Y. Okay. Well, let's go into edit mode and look at our curve. So a curve is made up of a few things. You've got two different points, and rather than being linear interpolation between those 2 points, what we have is we have a vector interpolation. So this curve has a direction, and it also has a magnitude like a vector. And as we click on the center vertex, the handles, as you scale the center vertex, you'll scale the handles. And that gives you a varying magnitude for the vector. You can rotate the vertex, and it rotates the handles or the vector direction. Now this is called the normal direction, and you can see that in the overlays menu. Under normals, you can adjust the size. I like to keep this on, and I'll explain why in a minute. But you can turn it off. It's easy to turn off. You can also turn off handles for your Bez curves if you want to. And you can hit S and you can still scale those handles. But something unique about Bez curves is the Beziers do have handles. And I want to cover the varying types of handles. So if you come into control points, there is a set handle type or the hotkey V. So when I hit V, you have various types of handles. As you highlight your mouse, you can select automatic. And automatic, as you move one handle type, it moves both. You can still scale the left or the right, but both are going to move together. If you hit V again, you can go to vector, and this is easier to show with one that's connected, so I'm going to extrude this vertex back. And as I hit G, I can move the handle all by itself. If you move the vertex, the handles are going to move with it, and notice that in the vector, the other handle is just moving around as I move the center. I can move the handles all by themselves. I can go to aligned and click this one and do aligned. And aligned is a lot like automatic. But automatic resizes. And I believe it interpolates a nice smooth angle as I move for an automatic alignment, the vector changes. If I have aligned, it's not going to scale. Okay? That's pretty cool. I mean, that's good to know those differences. Free, as I move this around, it's no longer moving like the vector is. Okay, so automatic movements versus manual movements, think of these two as things are adjusting for you, and these two as you adjust them yourself. And you can toggle between the free and the aligned. So as I toggle, it'll go back and forth. Okay? And that's one benefit of using a Bezier curve. So by this self, you can notice that you have a start point and the vector starts here. You have an end point and the vector ends there. Go ahead and delete that. We're going to add in the next curve, which is a circle. And the difference between a circle and a regular curve is you have a cyclic path. And I can come into the control points, or under the curve actually, and toggle cyclic. And notice how it's broken back into a curve, and it's no longer a circle. But I can toggle that back. And just like a regular, if I add in just a regular Bezier, I can do the same thing. Go into edit mode, and I can go to curve, and I can toggle it to be cyclic. And it closes the loop. So as I move this handle now, let's change that to vector. Right? Even though it's a closed loop, we're going from the last point back to the first point. Okay, we'll delete both of those. Oh, I do want to share one more thing. So just because it's a circle doesn't mean it has to be a circle. So if I come in here and I rotate, as I select all these, rotate by 45, and then I hit period to change individual origins for my scaling, I can hit S and go to 0. Look at that, we got a square. Curves are extremely dynamic, just like a mesh is. Another thing that you can do, now that we've covered all the handles, is you have interpolation between 2 points, but you can add another section between 2 points as well. All you got to do is select both, and you right click and you can go to subdivide. And now I've got 1 point in between. And you can choose the number of cuts that you want. And that's gonna set the resolution. We'll see the benefits of subdivision once we start making use of curves with other things. Let's go ahead and go look at NURBS curves. So notice how this is the curve here when you add it. But you have these control points that aren't necessarily physically attached to the NURB. And in the properties menu, let me go back to a Bezier. We've got, as I select this, you've got a control point that you can move left and right, obviously up and down, and forward and back. And as you move forward and back, those control handles are going to go from one point to the other, the starting vertex to the ending vertex. Well, on a NURB, you have the X, Y, and Z coordinates, but you also have a W. And as you adjust the W, it slams almost like a gravity effect where it pulls the curve towards the NURB vertex. And each NURB has its own W. I believe there is a total W, and as you increase them all together, it's just going to bring it back to the center. Each one provides its own amount of influence, and I can say, well, I don't want it coming closer to that one. I can bring it down or I can bring it up. So that's important to know. And for a regular NURBS path, the start of the curve is somewhere in between the first and the second, and the end of the curve is somewhere between the second to last and last. So as I extrude this out, this is now somewhere between here and here. And I can change how that's affected by shifting the W. This is one way of handling a curve. Now you don't have, normally you don't have handle types when it comes to NURBS. And that's, the calculation for a NURB is different than a calculation for a Bezier. It's just a different way of handling it. Both are powerful. They both have their own uses. I personally prefer the Beziers. That's just me. Let's go and add a NURB circle. And similarly to regular Bez circle, you can toggle the cyclic. We're just closing the gap. But notice how if I try to scale this with S, it's not scaling the same way. I can do median point and try to scale these two together. So there's ways to create, S0. I made a sharp end there, S0, I made kind of a sharp end there. So from this point to this point, S, I can't seem to close those two, S0. Okay, so you can still make polygons, but you have a smoother transition for the NURBS. You don't get the same amount of control, in my opinion. We also have a curve for the NURBS. It's called a path. And what's the difference between a regular NURBS curve and a path? Well, the path, you actually end the curve on the last point and you start it on the first point. And that's the main difference. Notice how the W is still set to 1. And as you move that, you can still control how much influence you have to the next point. But it's still going to start at the first and then at the last. And paths are pretty useful for parenting objects or using constraints and moving things along a path, because you have absolute control of where the path is actually going. A couple more things we can do with curves just by themselves. So add a Bezier, and if you have a tablet handy, so I've got an iPad Pro with Easy Canvas on my Windows machine, and when I come in here and I go into edit mode, we have some T options for our tool shelf that are specific to the curves. Now you've got your standard, move, scale, rotate, everything together. You can still draw. And you can measure between 2 points. But one really cool thing, if you're kind of an artistic mind, and it doesn't matter if you're in 2D or 3D, so I can come in here and on my tablet I can draw in a curve, and I believe by default it makes it a Bez curve, and it interpolates between the smoothness and figures out the angle for your corners, but you can adjust after you're done drawing. So let's say I only wanted this to be 10 degrees, or we can set it to split or refit. How much error do we want to maintain with that curve? Is how many subdivisions between each section are we going to allow? And it's an error amount in length, so 0.25 inches. We've got a lot more control points between each one. All right, as I bring this up to 1 inch. But this can make for, you can write out text. Right, and it's, when you're doing it in 3D, there's this imaginary plane that I believe cuts through wherever the 3D cursor is. And that's how you can get it in 3D. So that's another couple things I wanted to teach about curves themselves. You can also extrude from one section to another, or you can extrude multiple sections. So I've got 3 sections highlighted here, and I can extrude them out. Same thing as with hitting the E key. Okay. We have movement for, this is the radius, and this is some of these properties here. Now we'll cover weight. Let's get back to just a regular curve. And we'll get back to our regular selection menu. So we have a weight menu, or weight options, and this is for soft body physics. So you can set a weight goal for where vertices are being attracted. And I'm not going to cover that in this set of lectures. I'm going to cover mainly using curves in other ways, but that's got its own little workflow. Maybe at the end, maybe I'll get courageous and figure out how weighting works. As of right now, I don't know enough to teach it. Radius is setting how much influence each vertex has on the control handle from one point to another point, and this is going to get used when we're applying the curve and the modifiers. You'll be able to see it happening on 3D models and how the radius affects that. But just beware. And then tilting as well. Tilting is how the vector arrows themselves rotate in 3D space. So if I tilt at 90, it's going to start at this point at 0, interpolate linearly until it reaches 90. And you can see that. And as I extrude, it's going to maintain the tilt. So just be aware, if you have a tilt on a vertex for your curve, it's going to extrude that same tilt to the next one. And you can put this back down to 0, and it's just going to interpolate back from 90 to 0. Now with a NURB, I did want to note, let's delete this bez. You can also change tilt, but the interpolation, as far as I understand it, the interpolation is a lot less. So if I type in 180, this hasn't even spun an entire 180 yet, but as you swing the weight, you should be able to see that spin harder. So just be aware that with NURBS, you have to influence by the W influence, the weighting of individual NURBS. Now we have a menu over here on the side, and this is, I'm going to cover this in another lecture where I feel like it's a little more relevant. But I do want to cover quickly just converting curves. So if I have something like text, I feel like this is a pretty fun example. I can come into edit mode with tab and do all caps. Everybody loves caps, come on. Center along the world. And this is obviously text, so it's not a curve right now, but I can hit the space bar and go to find convert to, and I convert it to mesh, or I can convert it to a curve or a grease pencil. So let's go ahead and do curve, and I don't want to keep the original. When I go into edit mode, I had 2D selected, and there's a couple of things it does by default. It actually fills. We have a closed loop, and it is filling each one of these, and this is all considered one object, so a whole bunch of curves. And in between all the cyclic areas or the closed off areas, we're filling in between. And if I were to set this to none, be able to see that it's just the curve. And it's standard curve, so you can come in here and you can scale. Now, when you change the fill mode back to both, as you do front or back, it's not very handy for what I'm showing here. In the 3D view, we have different options, so like a half full back and front. And we have twist methods, and we'll cover those in a little bit. But I did want to show that you can convert from one to the other, and we can fill this to both. And you can convert, just like you can convert to a curve, you can also convert to a mesh. And notice how Blender tries to do its own little job of creating a plane. It's not the world's best. There are videos on how to convert this better into more usable geometry, but if you just wanted to grab all this A and extrude it up, you could do that right now. You got 3D text. Yay, that's pretty cool. But you can convert regular curves as well, and it'll convert them into lines or vertices. That should be good for this lesson. We'll go into the next study regarding making use of curves in more dynamic ways to affect our models in the next video. Thanks, guys.